Today we will be doing the experiment whose aim is to determine the head loss in case of sudden expansion or contraction or in case of bends. And in that we also calculate the head loss coefficient in each case. Now for this, the apparatus used is minor loss apparatus specially designed for this, plus a measuring tape and a stopwatch. Now if you see this diagram is reflecting the apparatus. Okay, in this apparatus there is the pipeline of 25 mm dia having various pipe fittings inside it. You can see here there is a small band, okay, there is a long band, there is a sudden expansion. Here the pipeline changes from 25 mm to 50 mm size, and after that there is a sudden contraction here. Here the dia again drop down and it drops to 25 mm from 50 mm. Now for measuring out the pressure loss, we are having tappings. We are having total 8 tappings for these 4 pipe fittings. Each tapping, one tapping is in front of the pipe fitting and another tapping is at the end of the pipe fitting, and each tapping is attached to this manometer for the measurement of the head loss in each case. And for the measurement of the flow, we are having a collection tank, and the measurement of the flow is very similar to what we have seen in case of our previous experiments. There is a measuring tank and we measure up the initial level, the final level, and the change in the level gives you the volume that has accumulated in that particular time. Now students, I will take you to the setup and show you all these points there also. Then we will perform one reading corresponding to a pipe fitting. I will take a reading corresponding to one pipe fitting and show you how to calculate the head loss coefficient in that case. Now we will move to the setup. Student, so this is our minor losses apparatus. You can see here the setup consists of a pipeline that is 25 mm in dia. There are pipe fittings, various pipe fittings. You can see this is a small band. Okay, this is the long band. There comes the sudden expansion, and after that there comes the sudden compression or contraction. So you can see there is a manometer for the measurement of the pressure. In fact, your head loss, and this manometer is attached to 8 tappings. You can see these are the tappings. There are total 8 tappings: 1, 2, 3, 4, 5, 6, 7, and 8. Now these tappings, they are attached to this manometer for the measurement of the head loss, and for the measurement of the flow, there is this measuring tank is there. The system is quite similar to what we have seen in other apparatus also. We will note down the initial level, we will note down the final level, and we will note down how much liquid has accumulated in that particular time. That will give you the flow rate. So now I am switching on my appraisers and I will take one reading. I will take one reading corresponding to a pipe fitting, okay, and show you how to take and how to calculate the head loss as well as the coefficient of head loss. Now students, I have switched on my appraisers and you can see the flow is taking place. The flow is taking place in this pipeline. So when the flow is taking place, there comes the first small band, then the long band, then sudden expansion is there, and then sudden contraction is there. For the measurement of the flow, you can come to the side. You can see here, I maintain the initial level to 3 cm. I have initially maintained this level to 3 cm. Now I will be diverting the ball and switching on my stopwatch, and I will measure how much volume has accumulated in 10 seconds. So for 10 seconds, the final level is 9 cm. So final level is 9 cm and the initial level is 3 cm. So 9 minus 3, 6 cm liquid has accumulated in this tank. Now for the measurement of the height or the head loss, you can see there are these 2 tappings are corresponding to the The minute change is only because the loss is the minor loss. The loss in the head is very small. So that's why there is a very minute loss. And for you, I will take one reading. One link level is 19.4 and other link level is 18.2. So left link is 19.4 and the other link, right link, is 18.4. So you can see here, I will move to the observation table and we will do the required calculation there. Student, so this is our observation table. Now we have done one observation corresponding to a short band. So type of fitting is band. So dia of the band, which is equal to the dia of the pipe, it is 25 mm, which will come out to be 2.5 centimeter. If you calculate the area of cross section by using pi by 4 d square formula, it will come out to be 4.906 centimeter square. Now this coming to this side, that is manometric reading. I have told you, and you have also noted down, the left link reading is 19.4 and right link reading is 18.2. So the difference in the reading is 1.2. This is in terms of mercury. Now if you want to calculate in terms of water, okay, so you have to multiply by that by the difference in the densities of mercury and water, which is 12.6. So you will multiply 1.2 by 12.6, you will get 15.12. So this is the head loss in terms of your water. So coming to the discharge measurement, initial level of the tank was 3 centimeter. Final level of the tank was 9 centimeter. So the time taken to rise the level of the liquid was 10 seconds. So using these calculations, and since the area of the tank is 40 by 40, using all these things, you can calculate your discharge, which will come out to be 960 centimeter cube per second. So this is your flow rate. Now we are familiar with the formula Q is equal to AV. So where A is the area and V is the velocity. Now if you want to calculate the velocity, you can simply divide your Q by A. You will get your V. So that is we are doing here. V is equal to Q upon A. So area is 4.906 and Q you have calculated, it is 960. If you divide 960 by the area, you will get 195.67. So this is the value of the velocity in centimeter per second. Now for the calculation of the coefficient of loss, we are very much familiar with this formula of head loss that we have seen in our theory class also, that for any pipe fitting, the head loss is given by HL, which is equal to K V square upon 2G, where K is the coefficient of your head loss, which is our objective to calculate. V is the velocity that is taking place through the pipe, and G is the acceleration due to gravity. Now, if you use this formula and manipulate this formula to calculate K, the formula will get converted to this form, where K will come out to be equal to 2G HL upon V. And if you substitute the value of G, HL and V, you will get the value for K. Now G you know, okay, it is the center value. Okay, so HL we have calculated, it is 15.12. V we have also calculated, it is 195.67. If you substitute this, the K will come out to be 0.77. So this is the value of head loss coefficient in case of your band, short band. So similarly, you can apply the same procedure to long band, to the sudden contraction, to the sudden expansion, and you can calculate your head loss coefficient for those pipe fittings. Now this experiment also proves that there is some loss. If you attach any pipe fitting to a pipeline, there will be a definitely head loss and its value will be very small. So that's why it is called minor loss. Okay, thank you.